Hey, good morning, everybody. A little bit icy out there, so get another delay, or I'm sorry, snow day, remote instruction day. So, real fast, I want to go ahead and I want to move past acceleration. I will project the answers for those problems when we get back to school on Monday. Second thing is that being that we're not in school, it makes it too cumbersome for me to try to evaluate you, and I'm going to push back the MUB mid-unit benchmark quiz on displacement, speed, average velocity, and that way we can do it when we're in school. So we'll just move into kinematics equation number one today. If we look at the table of contents, we're right here at kinematics equation number one. And kinematics equation number one, quite simply, is an equation that we already did. If we look at this equation, it's right here. It says that our VF, which is our final velocity, will be equal to our initial velocity plus acceleration times time. So today's lesson is basically just using this equation to solve kinematics word problems associated to this equation. Now, really, this equation is the same as what we did before. Acceleration equals VF minus VO over T, but it's just solved for VF. So this is really not a new equation, even though we called it a new equation, equation number one. It's the same as yesterday. So, that being said, hold on. That being said, we move into our first problem. And whenever we do these problems, we're going to identify the following variables. It's going to be VF, VOA, and T. So I want to go ahead and I want to put the equation here. And then what I want to do is I'm also going to make a text box to help us with identifying variables. So we're going to start with VF equals, whoops, VO equals, A equals, and T is equal to. So, all right, let me lasso all those together. No, I have to, let me lasso all those together. And that way we'll be able to solve these easier as time goes on right here. So let me go ahead and move this down, copy it again, and we're going to be, all right, we're good to go now. So let's go ahead and start to solve this problem together. So starting from rest, what that means, starting from rest, is that VO is equal to 0. We accelerate at 4. So rest means you're not moving. Okay, so we accelerate at 4 meters per second for a time of 6 seconds. So we know that the equation is equal to VF is equal to VO plus AT. So I'll plug in VO, which is equal to 0, plus acceleration, which is 4, multiplied by time, which is 6, ends up being 24. So we need to think about what we're looking for. We're looking for velocity, so it's 24 meters per second. Boom. Bring in and look at our next problem here, and we bring in all this formula and variables. We can see that if we start from rest again, which means that VO still is equal to 0, then we accelerate for 8 over a period of 9 seconds. That's going to be the time. VF is equal to VO plus AT, so it's going to be 0 plus A, which is 8 times 9. So I get 72. And just like before, because we're looking for final velocity, the unit is going to be meters per second. The next problem that we look at, we're going to see that we do have an initial velocity. Our initial velocity is not at rest. It says we have an initial velocity of 5 meters per second. So VO becomes 5. Then we know that we are going to accelerate in the opposite direction, negative 1.5. 5, negative 1.5 for acceleration. That occurs over 4 seconds. So let's go ahead and start to plug in some of this work here. If we see that VO is equal to 5, I want to go ahead and say 5 plus the A times the T, which is negative 1.5 times 4. Okay, so if we do the math here, it's going to say 5 plus, if I do negative 1.5 times 4, it's going to be negative 6. Okay, so if I do 5 plus a negative 6, my answer for VF is equal to negative 1, and of course meters per second. So I ended up with a negative meters per second final velocity, which just means moving to the left. It's a totally possible answer. Our next problem, we're still going to be looking for the final velocity. Well, we're going to start with an initial velocity of -3 meters per second. Just as a reminder, this O and this F and this initial and final, an easy way to remember it is VO means original, or you can think about it like start at 0. VF means final velocity, or the finishing velocity. So that'll help you maybe remember the difference between the two. It's the most common mistake is to mix those up. The acceleration is 2.5, and then the time is 9 seconds. If I go ahead and start to plug this stuff in, I say -3 plus acceleration, which is going to, VO was -3. Acceleration is 2.5 times 9. I don't have my calculator in my hand, so what I'm going to do is I'm going to cheat a little bit here, and I'm going to pull the tab right here. If we look at the answer, if I do that math, if I do 9 times 2.5, and then really I'm taking away 3 because I'm adding -3, the final answer becomes positive 19.5 meters per second. All right, in our next problem, what we're going to do is we're going to say that we're going to look for how much time it takes. So we're going to say time is equal to question mark. If we accelerate from 20 up to 100, and the acceleration is 1.5. So really, we're going to have to take and modify this equation right here, and I'm going to solve it for time. So time will be equal to VF minus VO. I like to put it in parentheses up top, all over A. So I'm going to go ahead and I want to do this math right here. I'm going to say VF was 100 minus VO, which is 20, divided by 1.5. So this is 80 over 1.5. So if I pull the tab and look at the time, after I do the math right here, oops, no, there's no answer on that one right there. So hold on, I want to pause and do the calculation. After doing 100 minus 20 divided by 1.5, making sure that you put these in parentheses up here, I get time is equal to an answer of 53.3 seconds. That's my calculation. Question number 39 now. It says how much time does it take if we start at rest? Okay, if we come to rest. If I go to rest, that means I'm going to 0. Final velocity 0. I started at an initial velocity of 5, and my acceleration is -2. So once again, time from the last problem is equal to VF minus VO over A. So I want to do the math here. It's going to be 0 minus 5, which is -5, over -2. So time, okay, if I have a negative over a negative, it's going to end up being a positive. So time is equal to 2.5 seconds. It's real important to know that you can't have negative time. Time is a scalar, so it doesn't have direction. If you have negative time, that means you mixed up VF and VO. Problems to do. Let's work on this problem now. It says an object accelerates at a rate of 3 meters per second squared for a time of 6 seconds until it reaches a velocity. Do we reach an initial or final? We reach the finish, so it's going to be final. What's the initial velocity? All right, so we're going to have to modify this equation too. I'm just going to give you the VO version. If VF equals VO plus AT, then VO will equal VF minus AT. Let's go ahead and set this up here. So it's going to be VF is 20 minus A, which is going to be 3 times 6. Okay, so if I can start with this math over here, if I do 3 times 6, that's 18. So 20 minus 18 is going to be 2 meters per second. So once again, remember that VO, just like VF, is a velocity. So it's measured in meters per second. One more problem. Last problem that we're going to work on today, it says an object accelerates at a rate of 1.5 for a time of 4 seconds. It doesn't say a time of, but notice it says 4 seconds. I should be able to look at that unit and say, oh, that's time, because time is measured in seconds. Until it reaches a velocity. Do we reach the final or original velocity? I always reach the end. I don't reach the beginning. I go from the beginning. It reaches a velocity of 10, and we're looking for this VO once again from the previous problem when we modified this equation here. VO equals VF minus AT. So it's going to be equal to 10 minus 1.5 times 4. I can do that math in my head. 1.5 times 4 is 6. 10 minus 6 means that VO is equal to 4 meters per second. That's a 4. And of course, that's a question mark. All right, so I want to give you a page to work on. Let me stop this video and upload it. I hope you have a good day, and please work on the problems that are attached in Teams.